Hello, geometry. So today we are talking about 4.2, which is reflections. We're not going to go super into this, okay, but I do want you to at least be able to reflect over the axes, and I want you to see reflecting over other horizontal lines or vertical lines. So what is a reflection? We know if we look in the mirror, we're seeing a reflection of ourselves, right? We see the image. That's what we're seeing in the mirror, and we are the pre-image. So a reflection, like you can see right here, is where we flip. All right, we flip or we reflect. We flip a figure. So here is our pre-image triangle ABC, and then A prime, B prime, C prime is our image, right? Pre-image, image. What's really important to note is that the line we reflect over is called the line of reflection. And there are many different lines of reflection that we could have. We are going to stick only with horizontal and verticals, okay? We're not going to go into anything crazy. So we can see in this one, like if I put my pencil here, we can see that this triangle ABC was reflected over the y-axis to get triangle A prime, B prime, C prime. So our line of reflection was this guy. And I try to draw my lines of reflection in green so you guys can kind of see where it is. Each point in the image is the same distance from the line of reflection. All right. So you can see here that C is 1 block away from our line of reflection, and C prime is 1 block away as well. Let me zoom in a little bit so you can see better. C is 1 block away. C prime is 1 block away. B is 3 blocks from the line of reflection. B prime is 3 blocks. All right. So another way of saying that is that this line of reflection is perfectly in the middle of triangle ABC and triangle A prime, B prime, C prime with respect to corresponding points, right? B and B prime correspond A, and A prime correspond C, and C prime correspond. So this is perfectly in the middle. And we can see here A is 4 blocks away from our line of reflection. A prime is also 4 blocks away. So really what we did was we just went like that, right? We flipped it over the line. This is, I'm going to zoom back out again so we can take a look at the rest of this. So this is a rigid motion. Okay, it's a rigid motion. That means the length and the angle measures of the image are congruent to the pre-image, right? They're congruent. So that's really important to note. Not all of our transformations are congruent. So let's take a look at reflecting over the x-axis and the y-axis, all right? We need to draw first our A, B, and C, triangle ABC. A is at 1 and 3. B is at -2 and +5. And then C is at 5, 6. So I'm going to use a ruler. Yes, you need a straight edge. Don't try and, eyeball it. Straight edges are best. There we go. There's my triangle ABC. We want to reflect it over the x-axis. So I have highlighted that in green here, like you can see. And so we want to reflect it. So here's what I'm going to do. I told you that A is going to be the same distance from the line of reflection as A prime is. So A is 1, 2, 3. That means I need to go 1, 2, 3. So that is where A prime is going to be. So let's do it for B now. B is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here's B prime. And then C. C is 1, 2, 3, 4, 5, 6. So C prime will be 1, 2, 3, 4, 5, 6. We can see that those are exactly the same size. We could prove it by using the distance formula, right? Ooh, the distance formula. It's like it never goes away. And now I can record what my points are. So A prime is at 1, -3. B prime, oop, I forgot to put my prime on there. B prime is at -2, 1, 2, 3, -5. And then C prime is at 5, -6. Do you notice a pattern with these? Do you notice a pattern? If I ignore these two, what's the same about A and A prime? What's the same? What's different? How are they different? If I cover up A and C, look at B and B prime, what's the same about B and B prime? How are they the same? What's different? How is it different? All right, let's look at C and C prime. What's the same about C and C prime? What's different about them? How is it different? So hopefully you notice that when we're reflecting over the x-axis, the y coordinates will change signs, right? The y coordinates will change signs. So if I have a point G that's at -3, 4, G prime will be at -3, -4. So the x coordinates did not change. They stayed exactly the same. And the y coordinates just changed signs. It went from positive to negative. That's it. So H and H prime. H is at 2, -8. H prime is at 2, +8. Right? Hopefully you saw that. Hopefully you saw that. So let's take a look at this one down here. All right, let's take a look at this one. And I probably won't connect them with my ruler. I'm just going to graph them for you. So we've got rectangle ABCD with vertices. A is at 2, -5. So here's A. B is at -4, -5. 1, 2, 3, 4, 5. 1, 2. Oh, 4. 1, 2, 3, 4, 5. C is at -4, -2. And then D is at 2, -2. Okay, I'm not going to connect those, but I'm reflecting it over the x-axis. So if I look at these, that means A prime, we just said that our x-coordinate stays the same. So I can go ahead and fill in a 2, B prime will be at -4, C prime will be at -4, and D prime will be at 2. And now I need to change the sign of my y coordinates. So this will go from a -5 to a +5. This will go from a -5 to a +5. This will go from a -2 to a +2, and this will go to a +2. So now I'm going to graph my primes without actually doing it, I'm not going to move them on here. I'm just going to try my new points and see if it works, see if that pattern holds. So we've got 2 and +5, 1, 2, 3, 4, 5. And then -4 and +5, 1, 2, 3, 4, 5. So that's A prime, B prime. C is at -4, +2, C prime, and then D is at +2, +2, D prime. Hey, look at that. That works, right? That works. So I'm being extremely careful, though I should be using a ruler. We can see that that actually worked. And you can see that A and B were toward the bottom of the page, but now it's C and D, right? It flipped. It completely flipped. It didn't just move. It flipped. It flipped over. So let's take a look at reflecting across the y-axis, all right? So we've got triangle, it should say RST, my bad. In triangle RST, R is at +7, -3, 1, 2, 3. So here's R. S is at 2, 1, 2, +6, 1, 2, 3, 4, 5, 6. So there's S. And then T is at 1 and 0. So there's T. So it's an interesting little triangle. It's not so little, actually. It's kind of big, isn't it? All right, so there's my triangle RST. And I want to reflect it across my y-axis. Well, T we can see is 1 block away. So that means I go one more. So this will be T prime. R is 1, 2, 3, 4, 5, 6, 7 away. So I have to go 1, 2, 3, 4, 5, 6, 7. So there's R prime. And then S is 2, 1, 2, so 1, 2. So there's S prime. So what are my new coordinates? Well, R prime is at -7, -3. S prime is at -2, +6. And then T prime is at -1, 0. Well, wait a second. Let's just take a look at those for a minute. Let's take a look at R. R and R prime. What's the same about R and R prime? What's different about them, and how is it different? What about S? What's the same about S and S prime? What's different about them, and how is it different? And then what about T? What's the same about T and T prime? How is it the same? What's different about them? How is it different? Hopefully you notice a little bit of a pattern here. So when we're reflecting over the y-axis, the x coordinates change sign, right? So if we have a v at -1, 6, then v prime, the 6 stays the same for the y coordinate, and it is our x coordinate that changes sign. It goes from a negative to a positive. So if z is at 7, -5, then z prime is at -7, -5. All right. So in this case, we've got the y, and our y stays the same. It's the x that changes. So we saw that up here with this one too, except when it was the x-axis, the x coordinate stayed the same, and it was the y that changed signs. So let's try out that rule for this guy. All right. So we have D prime. The y coordinate is at -3. So it's going to stay the same at -3, and our x will change sides. So this will turn into a +2. E prime, our y coordinate is going to stay the same. So it's at 6, and the x coordinate will change signs. So it'll be a +2. And then F prime will change from the 6 stays the same, but the -6 will turn into a +6. All right. So try graphing those, see what happens. All right, reflecting over vertical and horizontal lines, okay? So in this case, we've been given triangle JKL with vertices. J is at 1, -1, so here's J. K is at 2, +3, and then L is at 3, -2. So there's my triangle, something like that. We want to reflect it over the line x equals 4. Well, x equals, that's going to be a vertical line, right? It's going to be vertical. So I'm looking to reflect it. Now remember, when we're reflecting across anything, the distance to the line stays the same. So if we're reflecting across this line, that means this distance is going to be the same on that side, right? We just moved the mirror, basically. We can't use the trick that we just learned. We can't use it because it's not the axis, right? That trick only works on the axis. That pattern only works. So for this one, we actually have to draw it and move it, okay? So here we are 2 away with K. That means we have to go 2 more away for K prime. So what's the new coordinates of K prime? Well, it's 1, 2, 3, 4, 5, 6. And then we are at +3 on the Y. So then J is 1, 2, 3 away. So then we have to go another, let me zoom in a little. We have to go another 3. 1, 2, 1, 2, 3. There we go. So that's J prime right there. So that is at 7, -1. And then L is 2 away. So we have to go 1, 2, So here is L prime. So L prime is at 6, -2. All right. And that's the only way to figure these out. There's no other way to do it. We have to mark our line of reflection, which I've done in green, and then physically move the points. All right. That's the best way to do it. So let's try this one right here, and then I'll give you time to practice on 2 of them. This is a y = 2 for our line of reflection. So I've drawn the horizontal line. C is at -4, 1, 2, 3, 4, and then -4, 1, 2, 3, 4. So there's C. D is at -2, 0. E is at 6, 1. And then F is at 1, 2, 3, 4, 1, 2, 3. All right. So those are my 4. I'm going to connect them with a beautiful line. It's always better to connect them. I will tell you now, if I give you a quiz and you don't connect them physically, I will look at you and go, I don't know what that is. That's 4 points. So make sure you connect them. I say that after I didn't connect these. I got into a hurry. I don't like making these videos super long because I know that you get annoyed with me. All right. So we've got our points. Now we need to reflect it across our line. Well, D is 2 away, so that means D prime will be here. This will be D prime. C is 1, 2, 3, 4, 5, 6 away, so it will be at 1, 2, 3, 4, 5, 6. Whew, barely fit on there, but that's okay. E is 1 away, so E prime will be 1 away. And then F is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 for F prime. So our new coordinates for D prime are at -2, +1, 2, 3, 4. For C prime, it's at -4, and then that's all the way at the top, so it's at 8. E prime, it's at 6, but now it's at 3, 6, 3. And then F prime is at 4, but now it's up at 6. No, 7. Excuse me, 7. I miscounted. So those are our new points. All right, those are our new points. And you can see that they are equidistant, right? Like the line of reflection is perfectly in the middle in D prime, of E and E prime, of F and F prime, of C and C prime. All right. So try these ones. Try these ones. We've got triangle MNP being reflected across y = -5, and I have given you that line there. And then we've got square RSTU that's being reflected across x = -1. Okay? Try those out, draw them, see what happens. All right. And now we need to identify the line of reflection, the line of reflection. The easiest way to do this is to find the midpoint, all right? Find the midpoint between the pre-image and the image. So we're going to do this one together. Pick a point. Either pick M and M prime, pick J and J prime, K and K prime, L and L prime. Pick a point. That's the first thing, all right? Pick a point. Really, it's a set of points. I'm going to go with J and J prime. Or, yeah, J and J prime. That'll be fine. So they are 1, 2, 3, 4 spaces apart from each other. Half of that is 2. What is 2 spaces apart from them? 2 spaces apart is the y-axis. So that is their line of reflection, is the y-axis. All right, let's try this one right here. And I'm going to go with y and y prime. You can pick any of them, I promise. You'll get the same answer. How far apart are y and y prime? Well, they are 1, 2, 3, 4, 5, 6. They are 6 apart. That means we are looking at what's 3 away. Well, 1, 2, 3. 3 away is this line right here, which is y = 1. All right, so that is the line of reflection, is y = 1. And you can see that that's true, because if I draw it on here, you can see that's 3 away, and then that's 3 away. So we can see it. All right, this one's going to be a little trickier, especially for these points in here. These points are really hard to see. U and U prime, maybe V would be okay, but I'm just going to stick with T. T is nice and out there, and he's easier to see. So T and T prime, how far apart are they? 1, 2, 3, 4. They are 4 apart. Well, what's the middle of that? 2. So they are 2 away from the line of reflection. What's 2 away? Well, if I count in between them, 1, 2, it's the x-axis. The x-axis is 2 away. So we can see here that this is 2 and this is 2. So the x-axis is perfectly in the middle. So it is our line of reflection between our pre-image and image. All right. Please email me if you have any questions. I am happy to help.